All right, my friends, for 28, they definitely give you something to toy with. I honestly think that there's kind of a pattern with the last problem on this first section. They tend to give you something that's kind of I almost think of this one as like a bonus question where they're like, well, let's get those people who finish super fast. Let's give them something to do. So anyway, so just expect that typically is this last question on the multiple choice, on each multiple choice section is typically something that's, you know, kind of a little bit of a riddle. So anyway, let's see if I can figure this out. So you've got a particle moving along the parabola, y equals x squared minus x, with a constant speed of 2 square root 10 units per second. If dx dt is positive, what is the value of dy dt when the particle is at the point 2, 2? Okay, so let's think about this. They gave me this position function, and then they're kind of giving me like vector valued information. And so I'm going to reach for the definition of speed in terms of vectors, which is that speed is the magnitude of the velocity vector. So let's start with that because that's something that they gave us. Because they told you speed was 2 square root 10. So remember that speed is the magnitude of the velocity vector, which is square root of dx dt at whatever moment. In this case, it's at the point 2, 2 squared plus dy dt at 2, 2 squared. And then we can set this equal to 2 square root 10 because they said the speed is that. I don't know if I'm going to want to write that every time, but oh well, I guess I will. Okay, so actually, I don't want to write that. I just want to erase speed and put 2 square root 10 there. Because then in the next step, what I really want to do is square both sides to get rid of that big outer square root on the right side. So I'm going to square both sides, and then what would I end up with? I think I'd get 40 over there. Okay, so at this time, I have 2 unknowns, and so I'm going to need a second equation that relates those 2 unknowns, so dy dt and dx dt at the point 2, 2. So let's get that. So they gave us this equation, y equals x squared minus x. And we could get, you know, expressions for dx dt and dy dt. So let's see, how do we want to go about this? You know what we could do? Let's do dy dx. So dy dx is 2x minus 1. And dy dx at the point 2, 2 would be 2 times 2 minus 1, which is 3. And then if dy dx at 2, 2 is 3, then I could redefine dy dx as dy dt at that point over dx dt at that point. So that is 3. And then I could multiply both sides by dx dt to get dy dt isolated. So dy dt 2, 2 is 3 times dx dt at 2, 2. And how does that help? Well, I've got this is a relationship between the 2 unknowns, and this is a second relationship between the 2 unknowns. So I basically have a little system of equations, and I'm just going to use substitution to solve them. So I'm going to replace dy dt with 3 times dx dt right there. So I'd have, so this gets substituted into here. And I'd have 40 equals dx dt at the point 2, 2 squared plus 3 dx dt's at the point 2, 2 squared. And then if you squared this, you'd get 9 dx dt's squared, and you have one more, so 40 would equal 10 dx dt's at the point 2, 2 squared. All right, divide the 10 over. And then that would mean that dx dt at the point 2, 2 could have been either positive or negative 2, since you're squaring it and getting 4. But that's why they set up here dx dt is positive. So down here you could rule the negative out. And then if that's 2, then you could take that in right there. And that would tell you dy dt would be 3 times 2. Which matches up with D. All right, my friends, let me know if you have a smoother way to figure that out. But yeah, do expect that that last problem on that first multiple choice section does tend to be a little bit of a kind of a riddle. They like to set it up that way.